let us discuss the next operation, which comes under the category of forming. Okay, forming processes, and it is named as deep drawing process. In this process, the procedure is very simple. We have the sheet metal, okay, which is placed on a die. The die is having a shape. Imagine the die is currently a circular shape, a kind of cylindrical shape. Okay, so this is the cut section view. Generally, you will be having the die in a cylindrical shape. This is just for explanation purpose. Okay, so what's happening is we are placing the sheet metal on the die, and we are holding the sheet metal with the help of a holder, which is called as blank holder. Then the punch is applied from the top with certain force on the sheet metal, and it is applied up to the extent where the sheet metal reaches the cavity, in the end of the cavity of the die, basically. Clear? So that is the process what is happening over here. I've written over here also, deep drawing operation is a metal forming process in which the sheet metal is stretched into a desired shape. So what are we doing? We are just stretching it. We are applying certain force, and we are seeing that the material is stretched to form the shape of the cavity of the die. So initially you can just understand the sheet was maybe it would have be placed till this point. Okay, maybe it was up to this region when it was a flat sheet. Now as the pressure or the force is applied from the top side, what is happening is it is stretching downward. Then obviously it has to move this side, right? Clear? So that is the reason you're finding the sheet metal up to this region in this photo or this picture. And so this overall technique is called as deep drawing technique, basically, right? I'll just show you in the next slide more clearly. So you can see it is placed up to the larger extent. Clear? Then pressure force is applied from the top with the help of a punch, and the cavity is a circular cavity. It is a kind of cylindrical shape inside. Clear? Now what is happening is, as it is pushing down, you can see the material is moving inside, that is nearer to the cavity. Clear? And it moves down under the until it reaches the cavity, end of the cavity, and then it comes out, and the leftover piece will be in the form of a cylindrical shape. So you can see certain applications of this. For example, if we have the kitchen sinks, right, and if you observe that the kitchen sinks which are of sheet metal, generally those are processed or generated using this kind of operations also. They are basically flat, which they are applied with certain force in different shapes. You can find a rectangular shape of sink, you can find a circular shape, different shapes you can find, right? So that particular application is one of the thing what we can consider for a drawing operation. Clear? That particular product, basically. So this is a deep drawing technique. Now let us move to the next forming process, which is called as stretch forming. Clear? The name itself tells you that we are stretching the metal. Okay, but we are doing two things over here. I'll just read the theory. Stretch forming is a metal forming process in which a piece of sheet metal is stretched. This is the first thing, and bent. Please remember, we are doing two things over here. We are stretching the material. Stretching is very simple to understand, and bending is also very simple to understand. Let us look at the image over here. So you can see we have the die over here, we have the sheet metal, and we have a carriage over here which is holding the sheet metal from both the ends. You can see the holder over here. These are nothing but gripping jaws, we can call it. I've written over here gripping jaws. So you can see over here that they are holding the sheet metal on both the edges. Now what's happening is, with a force, this particular die is moving upward, and this particular force of the die, which is present in the form of semicircular shape, will try to bend the sheet metal, right? As this process is happening, in combination with this carriages or this holders are also moving on the opposite sides. You can see over here. So what is happening is they are stretching the metal, and this particular die is bending the metal. So this process is called as stretch forming, a combination of both. It depends on the application. Sometimes we can only stretch the sheet material with a minor bend, or we can increase the more bend with lesser stretching. It depends totally on the product application. Clear? But this is the technique on a very general note. let us move to the next slide. Now this process is very interesting. It is called as roll forming process. So I'll not read the theory, I'll just explain with the image over here because it is very simple to explain. Now what's happening over here is, you can see in this particular region, I'll take a different color. Maybe this color is good. Okay. So you can see this particular thing over here, the sheet is flatter in shape. Okay. It is a flat sheet. Now what's happening is, we are having different stations, station 1, 2, 3, 4, 5. So 5 stations are having different kinds of roller arrangements. This is a kind of rollers, okay, which are rotating at certain RPM. Clear? Now what's happening is, the raw material of the sheet metal is sent from the first roller. So this roller, you know, is a kind of flat roller. You can see the cross section, it is a flat roller. It is not having any shape which is found in other rollers. You can see different shapes are found in other rollers, but this particular roller, the first station roller, is a flat roller. So what is the purpose of this flat roller? We can say that the sheet is already flat when we are purchasing from the market in the form of raw material. The purpose can be 2 reasons. Firstly is to flat it again. Maybe there can be kind of bends over here because that is a raw material, right? In the transportation process, something could have happened to the sheet and it got bent at certain regions. So this roller is flattening it. Second thing is, it can also it can also reduce the thickness also. If the distance between both the rollers is reduced, then the thickness of the sheet metal can also be reduced. You got the point? Clear? So that is the 2 applications of the first roller. Then these are different examples of rollers, roller 2, 3, 4 and 5. So end product, let us look at what is the end product first. This is the end product. So you can see the cross section over here of the sheet metal which will be present after it crossed the final station. You can see it is in the form of this shape. Clear? So this is the shape of the material which is the end product. So if we are wanting the flatter sheet to get converted into this shape, we cannot do it in one go. That is impossible. So what can we do is, we can add different rollers of different shapes which help us to convert the flatter sheet into the desired shape. Okay, I hope you're getting the point. In order to convert the flatter shape into this end product, we cannot have a single roller. You cannot just directly take the final roller and try to send the flat sheet from this. In that particular case, nothing is going to happen because it is very difficult to send a flatter sheet in a roller which is having a very complex cross section. Clear? So what's happening is, we are first sending it from the flatter roller. We are either reducing the thickness, or we are flattening it again. Then we are sending it to a roller which is having a bit kind of change in the shape. We are just trying to change the shape of the profile. Okay, you can see over here it is having a kind of embossing over here, and it a kind of bending at the edges. Clear? You can see the formation over here. So initially it was flat, then slowly it is getting converted into this shape. Now that it got converted to this shape, we are reducing the overall width of the sheet metal by utilizing another roller. So you can see there are different forms of arrangement over here, and this is basically reducing the total length or the width of the sheet metal, and it is also adding certain thicknesses. I mean, it is increasing the depths also. Clear? So this is roller number 3. I'm sorry. Now we have the roller number 4, which is making or converting the sheet metal into a more detailed shape. Clear? And finally we have the 5th roller, which is the final output. So this is a roll forming process. It is a very interesting process. If you are really interested, just try to type the same name in YouTube or Google and you just try to see the video. It will be very fascinating to watch, and you can just understand the process of conversion of a flatter sheet into a kind of cross section which we are desired depending on the application. Obviously the application will determine the kind of roller what we are wanting, right? So depending on the application or the end product, the different rollers are designed and they are thought and arranged at certain distances. So generally it is not a very simple process. It takes a lot of thinking in the background, and then the rollers are designed, and then the roll forming technique is applied to convert a sheet metal from a flat to a desired shape. So this is all about forming processes, that is deep drawing process, stretch forming process and roll forming process. Let us continue the discussion in the next slide.